terrible. Trying to figure out what is possible. I never walked that because I was trying to find this last week.
I know, I think I walked all the way around the third floor.
Well, I went to the car sale. There's a sign that says no classes.
Yeah, I parked right out front today because I was like, oh my God, where's in this building? It was around. Like, I've been on the wrong floor. Where the, no, it's all.
These would make more sense for college business, because you walk in on the second floor there, and you just confused.
Right. Get all in. Get all out. I finally dropped history. I started the reading last night. It's not even like the book. It's just everything that was online. And then I looked at the 48 pages that we had to read for psych, and it was like, there's no way that will be different. And the cities was if I enjoyed it a little bit more.
We will start in 1 minute.
But yeah, I was.
Is this us?
Everybody else is online.
Oh, very cool. This might help me a lot, but.
In a few minutes, we'll start section 2.1b. This is the second part of solving linear equations. But first, we'll do a little bit more on section 1.3. Keep in mind that the first Newton assignment is due tonight by midnight. That's the section 2.1a on Newton. So make sure you get that done and stay caught up with the Newton homework. Yesterday we were looking at this sum of two fractions, negative 23 over 27 plus 4 over 15. And we found that the least common denominator, or the least common multiple of the denominators, is 135. So 135 is 5 times 27. 27 is this denominator. And 135 is also 9 times 15. So remember, before adding and subtracting fractions, you have to have a common denominator. So as an intermediate step, we can multiply the fraction negative 23 over 27. We can multiply that by 1 in the form 5 divided by 5. And the reason I chose 5 divided by 5 is because 5 times 27 is 135. For the other fraction, 4/15, we multiply this by 1 in the form 9 divided by 9. And that's because 9 times 15 is 135. So I'll continue this down here. When we multiply those two fractions, we get negative, let's see, in the numerator, 23 times 5 is 115. And in the denominator, 27 times 5 is 135. And then for the other fraction, in the numerator, 4 times 9 is 36. And in the denominator, 15 times 9 is 135. And now that the denominators are the same, we can add the fractions. So in the numerator, we can write negative 115 plus 36. And this is all divided by 135. Okay, so this will just turn out to be negative 79 divided by 135. You can check that negative 115 plus 36 is equal to negative 79. This fraction, we always want to see if we can write the result in lower terms, but this fraction is already in lowest terms. 79 is a prime number, and it is not a factor of 135. So this is the final answer. Okay, let's do a couple more. The next example, negative 3/4 minus negative 4/5. Remember, when you subtract the negative of a number, that's the same as adding the positive number. So let's rewrite this as negative 3/4 plus 4/5. That's what it means to take the negative of, or to subtract the negative of 4/5. You just add positive 4/5. And then we need a common denominator before we can add. So this one, the least common multiple of the denominators, 4 and 5. What is the least common denominator?
20.
Yeah, the least common denominator is just 20. 20 is a multiple of 4 because 4 times 5 is 20. 20 is a multiple of 5 because 5 times 4 is 20. Okay, so we can look at it this way. We can change those denominators to 20. And then we change the numerators in the same corresponding way. So this first denominator on the left is 4, but we want the new denominator 20. So if we multiply 4 times 5, we get 20. That indicates that we should multiply the numerator negative 3 by 5. So this numerator becomes 15 because 3 times 5 is 15. And then for the other numerator, well, compare the denominator 5 with 20. If we multiply 5 times 4, we get 20. So that means we should multiply this numerator by 4 also. 4 times 4 is 16. And now that the denominators are the same, we can add the fractions. We can do this directly, or we can put in another intermediate step. We can write in the numerator negative 15 plus 16 divided by 20. And negative 15 plus 16 is 1, so the final result is 1 over 20. Okay, the next one, negative 2/5 minus 1/8. Before we can subtract, a fraction from another fraction, we have to have a common denominator. The least common multiple of 5 and 8 is 40. So let's use a slightly different but equivalent method on the next one. We'll start with -2/5. We want to multiply by 1. The form 1 takes will give us the common denominator of 40. So what form should 1 take?
Positive?
8 over 8, right?
Oh, okay, yeah.
Yeah, 8 divided by 8 is 1. We chose 8 divided by 8 because 5 times 8 is 40. And then we'll do the same thing with the next fraction. Multiply 1/8 by 1. What form should 1 take this time?
5 over 5.
Yeah, 5 over 5. And then we get -16 over 40 minus 5 over 40. And -16 over 40 minus 5 over 40 is -21 over 40. This is already in lowest terms, but always get into the habit of checking and making sure that it is in lowest terms. Okay, the mixed practice, if we have time later today, we'll come back to this. This is just a little bit more of the same. This one's a little more involved because on this one we have to multiply the fractions first before we add it to the other fraction. For this one, we have to simplify what's inside each set of parentheses before we divide. And on this one, we have to simplify the numerator by adding the 2 fractions in the numerator. And then after that, we divide by the fraction 19/24. But let's go ahead and move on to the next section, section 2.1, part B. We saw this definition, these definitions on Monday when we covered Chapter 2, Section 1, Part A, but it's okay to read them again. A solution to an equation with a variable is a numerical value that produces a true statement after the variable is replaced with the numerical value. And then the definition of a linear equation in one variable. A linear equation in the variable x can be written in the form a times x plus b equals 0, where a and b are real numbers and a does not equal 0. We also covered the general strategy for solving a linear equation on Monday, but we'll just read through this briefly again. Simplify each side of the equation as much as possible. Then after that, collect all the variable terms on one side of the equation. Then once you've done step 2, step 3, collect all the constant terms on the other side of the equation. And then step 4, make the coefficient of the variable term equal to 1. So if you follow those appropriately, you'll end up with the variable equal to some number. And then in step 5, you can always check your candidate for a solution by substitution. I'm going to describe 2 methods for solving linear equations. So we'll have some examples where we have the same equation, but we'll use 2 different methods. So the first method is just to follow this the way follow the general strategy pretty much word for word. So we can simplify the right-hand side of this by combining in the like terms, 1/3 x plus 2/3 x. So let's simplify the right-hand side. 1/3 x plus 2/3 x is 3/3 x. But 3/3 is just 1, so we can write this as 2 equals x minus 1/2. And now we're just one step away from the solution. Add 1/2 to both sides. So 2 plus 1/2 equals x. As a mixed number, the solution is 2 1/2, but remember that in the Newton software, there is not a way to write down or to enter mixed numbers. So we have to write improper fractions instead. So we do that here, 2 plus 1/2. Think of 2 as 2/1. Before we can add fractions, we have to have a common denominator. So we convert 2/1 to 4/2. And then we add 4/2 plus 1/2, which is 5/2. Okay, so the solution that I got is x equals 5/2, or 5/2. The second method we'll solve the same equation. The second method involves finding the least common denominator, or the least common multiple of all of the denominators. Well, there are 3 different denominators. One is a denominator of 2. You can think of 2 as 2/1, right? But that's sort of inconsequential when we're trying to find the least common multiple of all of the denominators. The other 2 denominators are 3 and 2. So we really just need to find the least common multiple of 3 and 2. So just as a reminder, the multiples of 3 are 3 times 1 equals 3, 3 times 2 equals 6, 3 times 3 equals 9. I know this is tedious, but repetition is a good thing in arithmetic. So the multiples of 3 are 3, 6, 9, 12, 15, and so on. The multiples of 2 are 2, 4, 6, 8, 10, and so on. So the least common multiple
6
is 6. Okay, so now that we have found the least common multiple of all of the denominators, in this method, we multiply every term on both sides of the equation by the least common multiple, or the least common denominator. So multiply 6/1 times 2/1 on the left-hand side. Then multiply 6/1 times 1/3 times x. Multiply this number by 6/1. So minus 6/1 times 1/2. And then plus 6/1 times 2/3 times x. So it looks worse before it looks better, but the payoff is usually worth the effort, because when we're finished simplifying, we will have eliminated all of the fractions involved. Okay, so now we just do the arithmetic. 6/1 times 2/1 is 12/1, but we just want to write that as 12. And then we multiply 6 over 1 times 1 over 3 times x. So yesterday we talked about how to multiply fractions. We look for common denominators that cancels. So in this case, 3 and 6 have 3 as a common multiple. So 3 goes into 3 once, and it goes into 6 twice. So now we're just multiplying 2 over 1 times 1 over 1 times x, or just 2x. And then the next one, 6 over 1 times 1 over 2, or 6 over 2, this is minus 3. And then 6 over 1 times 2 over 3 times x. It's okay to do some of the work in your head. You just want to make sure you don't overlook anything. 3 goes into 3 once. 3 goes into 6 twice. And so 2 over 1 times 2 over 1 times x is 4x. Okay, so the result is an equation with no fractions. That's the payoff if you use this method. Because working with numbers that aren't fractions is usually easier than working with fractions. So now we just proceed. We can combine like terms on the right-hand side. Everyone remember what like terms are. Terms are like terms if they have exactly the same variable part. The coefficients, of course, can be different. The coefficients are the numbers that you're multiplying by the variables. So on the right-hand side, we can add 2x plus 4x to get 6x, and then we have minus 3. And then add 3 to both sides. 12 plus 3 is 15. 6x minus 3 plus 3 is 6x. And then divide both sides by 6. So 15 over 6 equals 6x over 6. 6 times x over 6 is just x, and then we want to write 15 over 6 in lowest terms. Lower terms than that. So one thing you can do, if you want to work on the side, this is the type of thing that we talked about yesterday. To write 15 over 6 in lowest terms, we can do a partial factorization. 15 is 3 times 5. 6 is 3 times 2. And 3 divided by 3 is 1. And so the fraction in lowest terms is 5/2. Hey, we get the same answer regardless of the method, provided no mistakes are made. Hey, well, sometimes method 1 is more straightforward, but at other times, method 2 will be more advantageous. So with practice, you'll sort of get a feel for which method you should use. Hey, let's do some more practice. Hey, on this one, let's use method 1. So we just proceed with the general strategy. Both sides are as simplified as they can be. So the next part in the general procedure is to collect all variable terms on one side of the equation and collect all constant terms on the other side. So we can do a couple of things at once on this one. We can add 1/4 y to both sides, and we can also subtract 1/2 from both sides. Are we in agreement that we can do both of those in one step? So on the left-hand side, I'll retain the 3/8 times y, but we're going to add 1/4 times y. On the right-hand side, we already have -3/4, but we're going to subtract 1/2 from both sides. So now all of the variable terms are on one side of the equation, and all of the constant terms are on the other side. So before we can add 3/8 y and 1/4 y, we have to have the coefficients have to have a common denominator. So the two denominators are 8 and 4. So what's the least common multiple of 8 and 4?
8.
Yeah, the least common multiple is 8. 8 times 1 is 8, and 4 times 2 is 8. So this term, 3/8y, stays the way it is because it already has the common denominator. And instead of 1/4 y, what do we want in its place?
2/8.
Yeah, 2/8y, 2/8 y. Hey, let's work on the right-hand side. The two denominators on the right-hand side are 4 and 2. The least common multiple of 4 and 2 is 4. 4 times 1 is 4, and 2 times 2 is 4. So the fraction -3/4 stays the way it is. And instead of -1/2, we want to write -2/4. Okay, now on the left-hand side, 3/8 y plus 2/8 y is a total of 5/8 y. We added the coefficients. 3/8 plus 2/8 is 3 plus 2/8. On the right-hand side, the common denominator is 4. What's the numerator?
-5.
Yeah, -5, because we have -3/4 minus 2/4. So the numerator is -3 minus 2, which is -5. Okay, now we're just one step away, 1 or 2 steps away from the solution. So we have a couple of options. In the end, we want just one y. So one option is to multiply both sides of the equation by the reciprocal of 5/8. So if you remember, you might remember, if you multiply a non-zero number by its reciprocal, you get a product of +1. So that's the motivation for multiplying both sides of this equation by the reciprocal of 5/8. The reciprocal of 5/8 is 8/5. Okay, so we'll multiply both sides by 8/5. So whatever legal thing you do to one side of the equation, you must do to the other side also. Okay, so 8/5 times 5/8 times y is 40 divided by 40 times y, but 40 divided by 40 is 1, so we get 1y, or just y. And then 8/5 times -5/4 Well, we can simplify this in a couple of ways. One way is to write negative 40 over 20. So be careful with the negative signs. Make sure you don't drop the negative. A positive number times a negative number is a negative number. And then negative 40 over 20 simplifies to negative 2. Okay, another way to do it, before multiplying the fractions, look for common factors that cancel from the numerator and denominator. So 5 goes into 5 once, and 5 goes into negative 5, negative 1 time. 4 goes into 4 once, and 4 goes into 8 2 times. Okay, so 2 over 1 times negative 1 over 1 is negative 2. So either way, we get negative 2 for the solution, y equals negative 2. Okay, below that, we have the same equation, but we're going to use the second method. Okay, there are 3 different denominators, 8, 2, and 4. The least common multiple of 8, 2, and 4 is just 8. Right? 8 is a multiple of 8, it's a multiple of 2, and it's a multiple of 4. So in this method, we just multiply every term on both sides by 8. You can think of 8 as 8 over 1, if that helps. It's not required, but it can help with the details of the process. So 8 over 1 times 3 over 8 times y plus 8 over 1 times 1 over 2 on the right-hand side. 8 over 1 times negative 3 over 4. And then minus 8 over 1 times 1 over 4 times y. It will look worse before it looks better. That's often the case in life. On this first one, 8 over 1 times 3 over 8 times y, 8 divided by 8 is 1. So this just becomes 3 times y. And then 8 over 1 times 1 over 2, 8 over 2 is 4. So we get 3y plus 4 on the left-hand side. On the right-hand side, 8 over 1 times negative 3 over 4. That's equivalent to 2 times negative 3, or negative 6. And then minus 8 over 1 times 1 over 4y. This is minus 2y. So you might agree, but in my opinion, it's easier to look at 3y plus 4 equals negative 6 minus 2y. I mean, it looks less confusing than what we started with. But that's just my opinion. Okay, so from here, we proceed with the procedure for solving equations. We can do a couple of things at once. We want all of the y terms on one side and all of the constants on the other side. So we can add 2y to both sides, and in the same step, we can subtract 4 from both sides. When we add 2y to the left-hand side, 3y plus 2y is 5y. And then we subtract 4 from both sides. Negative 6 minus 4 is negative 10. And then we can divide both sides by 5. 5y divided by 5 is y. Negative 10 divided by 5 is negative 2. Okay, the next example, well, just so we don't run out of time, let's just pick one or the other of the two methods. Instead of doing both, let's just pick one method. And then on the next problem, we'll pick the other method. So which method do you want to use on this one?
Yeah.
Second method?
First.
Oh, the first method? Dang. I always prefer the second method, but that's all right. Okay, so on this one, we subtract. We want to get all of the terms with m on one side and all of the constant terms on the other. So we'll subtract 1/5 m from both sides, and we'll also subtract 2/5 from both sides. So 1/3 m, and then minus 1/5 m. On the right-hand side, we already have, in effect, we already have negative 2/5, and we're going to subtract 2/5 from it. Okay, on the left-hand side, we have to have a common denominator. The two denominators of the coefficients are 3 and 5. And the least common multiple of 3 and 5 is 15. So we can replace 1/3 times m with 5/15 times m. And then you can always check. 5 divided by 15 is 1/3. And then for minus 1/5 m, we can replace that with minus 3/15 times m. On the right-hand side, we already have common denominators. So we can write it as negative 2 minus 2 all over 5. And on the left-hand side, 5/15 times m minus 3/15 times m. What does that simplify to?
2/15.
2/15
M.
times m, yeah. So 2/15 times m. And on the right-hand side, negative 4/5. Okay, then we can multiply both sides of this equation by the reciprocal of the coefficient of m. So in other words, multiply both sides by 15/2. So 15/2 times 2/15 times m. And on the right-hand side, we can multiply in either order. So I'll just write negative 4/5 times 15/2. On the left-hand side, 15 divided by 15 is 1. 2 divided by 2 is 1. So we get 1m or m. On the right-hand side, we get, one way to do it is write negative 4 times 15 is 60 over 5 times 2 is 10. And negative 60 divided by 10 is negative 6. So m equals negative 6. Okay, the next pair of examples involve decimal numbers. Well, decimal numbers can be thought of as fractions. Terminating decimals, like 0.9, that's really just a fraction. What fraction is it?
9/10.
Yeah, 9/10. And 1.25 is
1/4.
125/100, right? 0.75 is 75/100. 1.75 is 175/100. So I'm really applying method 2 on this one. So the least common multiple of the denominators, well, the denominators are 10 and 100. So the least common multiple of 10 and 100 is what? 100. Yeah, 100 is a multiple of 10 because 10 times 10 is 100. And 100 is a multiple of 100 because 100 times 1 is 100. So if we multiply every term on both sides by 100, we'll get rid of the decimals. You just have to make sure you're careful with the arithmetic. But whenever you multiply a decimal number by 100, the product will have the numbers with the decimal moved 2 places to the right. Okay, so I'll write this out in a little bit of detail. 100 times 0.9n minus 100 times 1.25. On the right-hand side, 100 times 0.75n, and then plus 100 times 1.75. So 100 times 0.9n is 90n, right? 90n?
Correct.
You see why that's true?
Yes.
So if you just focus on multiplying 100 times 0.9, remember what I said, multiplying a decimal number by 100, if you just move the decimal 2 places to the right, this is where the decimal started out, 0.9, move the decimal 2 places to the right, we get 90.0 or 90. Are we all in agreement about that? Okay, then the next one, minus 100 times 1.25. This is just going to be minus, well, in the decimal number 1.25, move the decimal 2 places to the right, so we get minus 125. Then on the right-hand side, 100 times 0.75n, 75n. And then 100 times 1.75, how much is that?
175.
Yeah, 175. So now we don't have any more decimals. So we'll just proceed. So in the next step, I'll start by adding 125 to both sides. So we get 90n equals 75n, and 175 plus 125 is 300. Then subtract 75n from both sides. 90n minus 75n is 15n. So 15n equals 300. And then divide both sides by 15. N is equal to 300 divided by 15. 15 goes into 15 once. In the numerator, you can think of 300 as 30 times 10. And 15 goes into 32 times. So that means 15 goes into 300 20 times. So n is equal to 20. Okay, the next one we'll use the first method. So in other words, we won't multiply both sides by the least common denominator. In general, you can use any method that you want, but we're going to practice method 1. But in passing, the least common denominator is 100 in this case. Each of the decimal numbers that we see have 2 decimal places. So the least common denominator is 100. I know you don't see a fraction, you don't really see a denominator, but there is a denominator there. Okay, and in this one, we'll start by distributing multiplication over u plus 8 by 0.10. So we get plus 0.10 times u, and then 0.10 times 8 is 0.80. And on the right-hand side, 2.15. On the left-hand side, we can combine like terms. 0.05u plus 0.10u is 0.15u. I'll go ahead and write plus 0.80 equals 2.15. And now we're going to subtract 0.80 from both sides. And so we get 0.15u equals 1.35. And then we just divide both sides by 0.15. When we divide both sides by 0.15, we get u equals 1.35 divided by 0.15. And this we have to simplify further. So any ideas? Well, you're allowed to use a high-powered calculator or those TI 30 something.
Hey, they're 38, I think, is what the syllabus says.
Yeah. So, but if you want to get better at arithmetic without relying on a calculator, we can do a couple of things. We can multiply by 1 in the form 100 divided by 100. So in the numerator, 1.35 times 100 is 135. In the denominator, 0.15 times 100 is 15. And you can note that 135 is 9 times 15. 15 divided by 15 is 1. So the solution is u equals 9. So even though you're allowed to use a calculator, I'll still encourage you to try to do a lot of the work without a calculator. Because if you get a sense of what an answer should be, then if you do something wrong, you'll be more apt to check your results. If you always rely on a calculator, then whatever it says must be true, but that's not always the case. Okay, we have a few minutes left. Let's let's look at the next ones. Use any method that you want. 1.2v minus 0.91 equals 0.8v plus 2.29. So what method do you want to use on this one? You don't have to pick method 2 if you don't want to. But
Method 1.
you want method 1? Okay.
Yeah.
All right, so we'll proceed. We'll subtract 0.8v from both sides. So 1.2v minus 0.8v. And in the same step, we can add 0.91 to both sides. So we get 2.29 plus 0.91. And on the left-hand side, 1.2 minus 0.8 is what the coefficient of the variable v will have to be. And that's just 0.4v. And on the right-hand side, 2.29 plus 0.91, that is just 3.20. But another thing about decimals, 3.20 is equivalent to just 3.2. And then divide both sides by 0.4. So v is equal to 3.2 divided by 0.4. So what is 3.2 divided by 0.4 without using a calculator? Yeah, it's 8. If you multiply by 1 in the form 10 over 10, 3.2 times 10 is 32. Move the decimal one place to the right. 0.4 times 10 is 4. 32 divided by 4 is 8. Okay, we have less than 1 minute. On this one, I would advise using multiply both sides by the least common multiple of the denominators, which is 14. And make sure you don't overlook multiplying 2 by 14 on that one. Okay, but we'll go ahead and take attendance now. So if you're online, type in your first name followed by your last initial. And I'll take attendance here. Victor Barth, Sadie Becker, Hammond Coles, Jesse Hutt, Bailey Bourne, Evelyn Hall, Carter Hill, Nicholas Holman, Calvin Hannes, Melissa Jones, Anthony Holt, Michael Montoya, Soraya Bloody, Alec Heron, Jared Heron, Richard Van Lees, Noah Redford. What's that?
Did you say no, Richard?
Richard Van Lees?
Yeah.
Yeah, that's you. I got it. Noah Redford, Raymond Weber, Mariah Parrish, Joseph Von Spence, Autumn Victoria. Anybody's name I didn't call?
I just added
What's your name?
Travis. Yep. Yeah, I'm probably not on that.
I have really bad hearing, so
Me too. This will be fun. Yeah. I haven't been there. I just got added to the class.
you got it in my class. When?
Yes.
I checked it yesterday and I didn't see.
You know the name of your instructor?
I don't, we
I
need
know
to verify. Yeah, this is section P. Oh, math 1108P, section 1. This is something that I want. 306.
Okay. Well, thanks for teaching me today.
Yeah.
Yeah, this building.
Yeah, you write your name and then I'll be sure that I'm sorry. Oh, talk to your instructor.
Go ahead, Mike. I'll just walk over there. Just tell them that I.